I have been using U7 Pro Max for about a year. Recently, Ubiquiti introduced Pro-XGS and sent me one. In this video, I'm going to look into it. You can see the biggest apparent change is the form factor. Now the front part is very flat and the back part is metal and for better heat dissipation. Let me compare the Pro Max and the Pro XGS side by side. XGS has a little bit larger diameter. It's even thinner. They have almost the same weight. The top left, U7 Pro Max, top right, E7, bottom left, E7 Campus, bottom right, U7 Pro XGS. The XGS is in round shape. It looks like the original Pro Max, but from design perspective, it's more like the E7 and the E7 Campus. The front is flat, the back is in metal. In this video, we will discuss CPU and memory situation, the MLO support, throughput testing, spectrum analytics, power consumption, and the temperature. This is the radiation pattern from Ubiquiti. From pattern perspective, they are not very different, which means they are supposed to be used in the same scenarios. Here I'm comparing the specifications for these two UniFi access points. So you can see the XGS is $20 more expensive than Pro Max. Here I'm only displaying the unique specs. Of course, the biggest difference from spec perspective is the uplink speed, right? We will talk about this later. Because of more power consumption needed, XGS requires PoE++. That's another big difference. And for all other differences, yeah, they have slight antenna gain difference, but not too much. In the technical specifications, I cannot find any information about CPU or memory. Of course, for access points, that's something most people don't really care, right? But I really want to understand just from the change perspective. Yes, we all know the form factor change, the uplink speed change, but what else, right? So let me go to SSH to find it out. This is my lab environment. You can see I have both access points connected, U7 Pro XGS and the Max. In the right side, in the two terminals, let me SSH into these two APs. Okay, I'm in. So normally, if you want to show the CPU details, you can run ls CPU in Linux. But this access point comes with a simplified Linux distribution, so it doesn't have this command. It doesn't matter. We can get the same information in another way. So let me run this command, cat proc CPU info. Okay, it returns 4 CPU cores. You can find out the model name and even the Bogor MIPS, the rough speed. And then let me run the exact same command in another AP. Okay, you can see the returns are exactly the same, even including the Bogor MIPS speed. So which means they have the exact same 4-core CPU. Then move on to memory. Let's see whether they are also the same. From the U7 Pro XG, let me display the memory information. If you go to the beginning, you can see the total memory is about 1.8 gigabytes. Then in the U7 Pro Max, let me run the same command. Okay, now you see the difference, right? It's only about 800 megabytes, less than half of the new U7 Pro XGS. Ubiquiti does increase the memory, enhance the hardware, but it's not mentioned in the specs for some reason, which is a good thing, right? That's a bonus. XGS stands for 10G and spectrum analysis. We will talk about these two main features later. Before that, I really want to understand the MLO support for this access point. Because if you compare it with the Pro Max, in Pro Max, Ubiquiti does mention MLO, and you can check my previous video about its MLO support. But for this U7-Pro-XGS, I cannot find MLO is mentioned anywhere, even though I doubt it has any difference with the Pro Max when it comes to MLO, but I still want to confirm that in my own testing. Let me explain my UniFi lab environment setup first. I have a XG6 PoE switch to provide PoE++ and 10 gigabit uplink. Then for this U7-Pro-XGS, if I go to settings, you can see for 5 GHz and 6 GHz, I set them to the widest possible channel width, which are supported by Wi-Fi 7. And for channel, I set them to auto. And here you can see the current effective channel and the channel width, right? Then if I go to Wi-Fi SSID setting, you can see I created this MLO XGS SSID. It's only broadcasting using this Pro XGS, and then I set the Wi-Fi band to 5 GHz and 6 GHz, and I enabled MLO. So basically, if the access point support single radio MLO only, the client can only use one of the Wi-Fi band during runtime. But if the AP and the client both support multi-radio MLO, both Wi-Fi bands will be utilized. So let's see what will happen in my testing. In the lower part of the screen, in this Windows machine, it uses a Intel BE200 Wi-Fi card. It only supports single radio. You can see I already connected to this MLO XGS SSID, and in the details you can see yes, it's using Wi-Fi 7 and the network band are both, which means MLO is used, and you can see the speed for the two directions. They are not the same. For one direction is ridiculously fast, but sometimes the display from the client is not really accurate. So in the UniFi network controller, let me go to client devices. Then for this Windows client, see the standard is Wi-Fi 7 MLO, and see the two Wi-Fi bands. For 6 GHz, it displays the signal strength, which means currently it's being used, and for 5 GHz, it says ready. Even just by checking this display, it already implies currently the single radio MLO is used because only 6 GHz is being active. And then when it comes to speed, here you can see more accurate RX rate and TX rate. Apparently they are showing different value than the Windows client, right? I trust this UniFi display. Okay, so this is what we can see from the available UI, but I still want to confirm in lower level by using frame capturing. So let me do that. In the lower left, I have a Mac machine. So I launched the Mac standard sniffer application. Then here, I set the channel to 53. Why? Because from UniFi network controller, you can see the current active channel for 6 GHz is 53, right? And because currently Mac machines, even the most high-end one, they only support Wi-Fi 6E. Yes, they do support 6 GHz, but not Wi-Fi 7, which means the widest channel width I can select in the Mac sniffer is only 160 MHz. But from the access point perspective, it supports Wi-Fi 7, so the channel width is 320 MHz. But it doesn't matter for my use case now because I only want to capture the frames to see the MLO capability, right? Just by using the 160 MHz, I'm good already. So from the Mac machine, let me start capturing. Okay, then from the Windows machine, let me stop Wi-Fi and connect to this SSID again. Okay, reconnected. Then in the Mac machine, let me stop capturing. In Wireshark, let me display the captured frames. There are a lot of different Wi-Fi frames. We don't have time to explore them all, but let me show you 3 different frames. First one, let me show you this beacon frame from the AP. So this is just a broadcast frame. It's not specific to any client. So this frame will represent the capability of the AP, regardless what client. Click on this frame. In the packet, let me go to this wireless management, tagged parameters, then go to this part, the multi-link section, and then expand the common info. Here you can see the EML capability. It support EML SR. SR stands for single radio MRO. Yes, it's supported. But let's say EML MR, the multi-radio MRO, no, it's not supported by this AP. The exact same situation as the other access point, U7-Pro-Max. Then if we go to this section, MLD capability, you can see the maximum number of simultaneous links is 1. 1 means it supports 2 simultaneous links. So this is the beacon frame. And then if I show you another frame, see this one, this green one, let me highlight it. This one is association request, which is sent from my Windows client to this access point when it tries to connect to the Wi-Fi. Let me go to the exact same section of the captured frame, multi-link section, common info. This represents the Windows client's capability, not the AP. See, it supports SR and it doesn't support MR, the same as the AP, right? If we go to the MLD capabilities, maximum number of simultaneous links is 0, which means it can only support 1 simultaneous link. This is also expected. And the very last frame I want to show you, if I scroll down, yes, this purple color one, association response, let me highlight it. So this one was sent from the AP back to the Windows client to accept the connection. This frame should represent for that particular connection what's the capability. If I go to the exact same section for multi-link support, common info, for EML capability, the exact same situation, it only supports SR, not MR. Then for MLD section, yes, the same value 1. Here we see the exact same information as the beacon frame. Nothing's changed. By briefly checking these 3 example frames, my conclusion is this AP only supports SR single radio MRO. The Windows client only supports single radio MRO as well. However, I do not have a Wi-Fi client which supports multi-radio MRO to 100% confirm my theory. Okay, so nothing's changed if we compare it with the previous U7-Pro-Max. Let's move on. Now let me test the overall throughput of this access point. If you compare this AP with previous U7-Pro-Max, the biggest change is the uplink. This AP has 10 GBE uplink. The Pro Max only has 2.5 GBE. So you may wonder whether this is really necessary. Uplink speed for this AP, whether it can even succeed 2.5 GBE, right? Let's test it. For this access point, if you check the MIMO, you can see only for 5 GHz, it comes with 4x4. For max data rate and also for 5 GHz, the data rate is much higher than 6 GHz and 2.4 GHz, right? Because of these specifications, I'm going to test the throughput in this way. I have a Ubiquiti's old 10 GBE PoE++ switch, and I connect this AP to this switch, and I also have a dedicated Mac which has 10 GBE connection. I will run multiple iPerf3 servers, and on the air I run totally 8 Wi-Fi clients. 2 of them will be using 2.4 GHz. 4 of them will be using 5 GHz because for this AP 5 GHz has the most throughput, right? And then 2 of them will be connected with 6 GHz. So you can see for each Wi-Fi band, I have mixed usage of the client machines, Mac or Windows. And when it comes to 6 GHz for Windows, yes, I'm going to run a computer which support Wi-Fi 7. But for Mac machines, the best I can have, which support 6 GHz, is to use Wi-Fi 6E, which will still use 6 GHz, but it won't take full potentials of 6 GHz for this access point, but it doesn't matter because my goal is to test throughput instead of a single client's performance, right? Having said that, let's go to the testing environment. You can see these 8 client machines. I will be running iPerf3 clients on them, and this is the Mac machine, which will be running 8 parallel iPerf3 servers. Of course, each one of them will be using different parts, right? So let me kick off the 8 servers first. Okay, 8 servers are running. Then let me start from the first client, this Mac machine. So I'm going to run the client in this mode first. Use a distinct port number, run it for a long time, then run 10 parallel threads. And you can see I don't have the direction specified. By default, it will be sending or uploading. Okay, let me run it. Yeah, you can see from the server it's running. Then go to the Windows client. It's also connected to 2.4 GHz. Run the client in similar way, of course, to a different port. Start it. Then the first 5 GHz client, right? Then proceed to other clients. Then move on to 6 GHz clients. Okay, all of the 8 clients are super busy now. Then if I go to the server, let me launch the activity monitor. For network, you can see the current receiving speed from the server perspective. It is over 400 or even 500 megabytes, which means it's close to 5 gigabit per second. It's pretty good speed, right? It already exceeded 2.5 gigabits per second. So yes, the answer is this 10 gigabit uplink for this access point makes sense because it's possible you have scenarios that you do need over 2.5 gigabit per second. Okay, keep in mind all of them are running in one single direction. So you know, if I change the testing to both directions, the speed will be much slower. Let me do it anyway. Okay, go to the first client, kill the existing one, rerun the command. Here I will specify bi-direction. And then go to this Windows client, rerun it by direction. By the way, I'm running this iPerf3 client in this Windows machine using the Linux subsystem instead of directly from the Windows command line. The reason is the iPerf3 client for Windows doesn't support bi-direction, but the Linux version does. So that's why I'm running it in the Linux subsystem. Okay, right? So do the same thing in all other clients. All 8 clients are using bi-direction. So you can see the speed for upload and download. They are not really even for this particular testing. Upload from client perspective or download from the server perspective is much faster depending on how, when, what type of clients you run it, and depending on your Wi-Fi environment, your result may be different. So every time it won't be very equal. But anyway, you see even for bi-direction, you may still exceed the 2.5 gigabit per second limit, which are on the U7-Pro Max, but not on this access point, which is good. Well, now let's talk about the S in the model name XGS, which represent spectrum analytics functionality. So in UniFi Network Controller, if I click this AP, you can see there's a button here. It's called Air View. If I click on it, if your access point supports the spectrum analytics, you will see this environment button. Let me click on it. It will do the initialization to go into the analytics mode. So here I have the same complaint, because every time, for the very first time, if I wanted to use it, it always runs for a long time. Sometimes it will be successful, sometimes I need to restart it. It's the exact same behavior as in my previous U7 Pro Max. So there's no improvement here for this XGS. I guess it's simply due to the resource constraint in the AP. So the AP is not fast enough to react on it. So you can see after such a long time, it's still analyzing. Okay, after about 2 minutes, finally, the display is fine. Now it's showing the 2.4 gigahertz Wi-Fi band. So this is the real-time spectrum analysis. You can see for this particular area, it says this AP, right? Why is so busy? Why is so red? Because I'm doing the throughput testing, right? But outside of this area, for other area, you can see it's also very red. Why? Because this is 2.4 gigahertz Wi-Fi band. So my neighbors are also busily using this Wi-Fi band, right? And then here from the waterfall, you can see the history. You can see for this area, it's completely dark red because I'm busily doing the throughput testing, right? Then if I switch to 5 GHz, yeah, for this Wi-Fi band, see this wide area, because of the capacity of this Wi-Fi band, it's not as busy as previous Wi-Fi band, but still in this area, you can see some areas are showing dark red all the time. And then for 6 GHz, yeah, this is the channel width. For my SSID, you can see some areas are showing dark red, but it still has a lot of potentials to support other clients if I have. That's the nature of the 6 GHz, right? You can see for all other areas, it's pretty green because none of my neighbors have 6 GHz, which means at this moment, if I want to utilize all the potentials of my clients, I may want to consider 6 GHz if they support it. Okay, so this is just a brief look into the analytics of Spectrum. Because this AP supported, that's what the S stands for. Well, now let's talk about power consumption. As mentioned previously, this U7-Pro-XGS access point requires PoE++. And I connect to the UniFi switch US-XG6 PoE, which does support PoE++. So if I show the port manager for this switch, you can see this first part is connected to U7-Pro-XGS. So from the overview of the UniFi network controller, if I move my mouse over to the port 1, you can see the current power consumption, which is 19.10 watt. This is the power consumption when I have all the 8 clients busy doing throughput testing. So it's not too bad. At least based on this current power consumption, PoE plus is enough. I don't really need PoE plus, right? But for some extreme scenarios, for example, for startup or for some very busy situation, you may still need PoE plus. Otherwise, your AP won't work. Just as a comparison, this is when the AP is completely idle, meaning it doesn't have any Wi-Fi clients connected to it. So you can see now the power consumption is 16 watt. Sometimes it will be 13, 14 watts. It's fluctuating. But if you see the other part, which is connected with the U7 Pro Max, is only 11.5 watt. This U7-Pro-XGS consumes more power, even when in idle mode. As the last topic, let's talk about the temperature. So while the throughput testing is busy working, in fact, it's already been working for more than an hour. This is the current temperature situation. From the front, you can see the hottest area is about 120 Fahrenheit. But the back is much worse, so the hottest spot is about 155 Fahrenheit. It's very hot. I hope this sign only means this AP has better heat dissipation so that it can dissipate the heat much faster, instead of meaning this access point has worse temperature situation. I hope so. Okay, this is the end of the video. Thanks for watching.